Okay, so at the end of the last video, we were just reviewing the adding sig figs. Okay, so let's suppose we have, and we said we add the one, we keep the least number of decimals. So first let's add these. So 36.85, 202. Okay, so when we add these, it's going to be 238.85. Okay, so that's our complete number. But now how many sig figs am I allowed to have? Well, this one has 4 in total, this one has 1 in total, and this one has 2. But when we're adding, it's really all about the number of decimal places. So this guy has 2, this one has none, and this one has 1. So my final answer is actually not allowed to have any decimal places. Okay, and you might have said, oh, I can only keep one significant digit total. No, it's the number of decimal places. So I got to get rid of this 8.5, but I can't just drop it. It's greater than 0.5, so I need to round up. So this will become 239, and this is my final answer. But please, when you're doing these, always write the unrounded number, like the full complete answer out, and then go to the number of sig figs. That way, if you screwed up, at least I know you had the right answer, and you just screwed up trying to get the right number of sig figs. Okay, so that's adding and subtracting. Multiplying and dividing are a little bit different. For multiplying and dividing, it's actually the number of sig figs in the full question. So when multiplying or dividing measured quantities, the calculated answer should be rounded to the same number of significant digits as are contained in the quantity with the fewest number of sig figs. Okay, if this is the only operation. So for example, 1.23 times 54.321. When you multiply that, you get 66.81483. How many sig figs am I allowed to have? Well, the first number has 3, the second one has 5, so in the end, I'm only allowed to have 3. So this will be 66.8, and we drop the 1483, okay? Then, what if it's a series of calculations? What if, for example, you're multiplying and then you're dividing by something that has 2 numbers that were being subtracted? So first you do the series of operations, so we can subtract this 3.45 and 3.21 and get 0.24. We can multiply 1.23 by 4.321 and get 5.31483. And now we're going to divide these two, and so we get 22.145. But when it's a series of calculations, you go back to the original numbers, and you see you keep the smallest number as sig figs. So this one has 3, this one has 4, this one has 3, this one has 3. So the answer can only have 3. It's going to be 22.1. You do not round along the way. Okay? So you keep all of the decimals in these 2 steps, and you only round at the end. Please, please, please. All right, the last piece with the part with sig figs is that sometimes you have what are called exact numbers. So for example, if I was counting the number of people in the room, it might be 17. It wouldn't be 17.1 or 16.8 unless one of you left a body part lying in the hallway, and try not to do that. Okay, so they're called exact numbers, so we assume they have an infinite number of sig figs. For example, like a carton of eggs has 12 eggs. We're not going to be limited here and say that this number only has 2 significant digits, because we know it's a perfect number. Okay, it has infinite precision. And so when we do this math here, 12 eggs times 52.3 grams per egg, our final answer will end up having the number of sig figs as the 52.3. So it should be 3 sig figs because 12 doesn't enter in. It's a perfect number, an exact number, a counting number. Okay? And then the last note here is for rounding. So if you're going to round, for example, this 1.2345, you're going to round it to 3 decimal places. You go to the, or 3 sig figs, you go to the 3 in the decimal place, and you look to the number to the right. And the number to the right is a 4, and so the 3 doesn't get rounded up. Now, what some people want to do is they want to say, no, the 4 would round up to a 5 because of this 5 here, and then because the 4 is a 5, the 3 rounds up. No, we don't care about what comes after the 4, we just care about the 4. It's less than 5, and so the 3 stays as a 3. 13.65 rounded to 3 sig figs. This time the number after is 5 or greater, and so the 6 rounds up, it becomes 13.7. Okay, so now what I'd like you to do for homework is this sheet. So I gave it to you in the stack of sheets in your when you were in class. Okay, the front side, put your name on it, and the front side, it just wants to know how many sig figs do these have, so just list them down. The back side wants you to do the calculations. The top line is for the full and complete answer you get, not paying any attention to sig figs. The second line is where you put the answer with the correct number of sig figs. Okay, so notice it mixes up, multiplying, subtracting, dividing. Now, if it has units, then remember your answer has to have units. So when you do 34.8 kilometers plus 14 kilometers, you need to have units in your answer. It'll be kilometers. Remember, if you're multiplying meters by meters, you should get meters squared. If you're multiplying or dividing a number with units and a number without, then it'll just be the units. So this will end up being centimeters. You need to be careful of 2 of them. This one, the last one, first one in the last column, and the last one in the third column. You need to be careful because you have a meter and a centimeter. So you need to change. I would say maybe change the meter to centimeters, but you need to change. There's 100 centimeters in a meter, so one of them needs to change. And as soon as you do that, then it becomes a calculation with multiple steps. Right? Because you've changed one of them and then you've multiplied. So it becomes a calculation with multiple steps. Okay? And the area of a circle, the formula is A equals pi r squared. So could you do this for your homework? And I'll go over any questions the next day you're in class, and then I'll probably say, could you hand it in so I can see if you got it. So you're going to finish the trig sheet nice and neat on loose leaf. And you're going to hand that in, but again, I'll take any questions before you do. And then you're going to do both sides of the significant figure worksheet and hand it in after we take questions. Okay? The only other thing, since I have 3 minutes, I said I would come back and talk about scientific notation. So just for a second. So the rule, I just want to go over it. The rule for scientific notation is the number in front of the decimal must be between 1 and 9. So, oops, sorry, I was looking for the sheet I was writing on, trying not to waste too much paper here. So if I have a number like 100.634, and I want you to write it in scientific notation, I move my decimal so the number in front is between 1 and 9. So it goes to here, 1.00634 times 10 to the, and then I count how many places I moved it, 2. I moved it to the left, so it's positive. If it was 0.000572, then I need to move it so the number in front of the decimal is between 1 and 9, so it'll become 5.72, and then I count 1, 2, 3, 4. I've moved it 4 places, but this time to the right, so it's -4. In the end, the number of sig figs in the answer has to match the number of sig figs in the original question. Okay, so the top of this page just talks about how to do scientific notation. In class on the next day, we'll go further, but I just want to show you that because there's a couple of scientific notation ones on your sig fig sheet. One there, and maybe one in the back. So I just didn't want it to screw you up, okay? All right, we'll see you next class day.